Hi, and welcome back to the final week of our course From Media Computation to Data Science. This is the week where we'll be putting it all together, where we're going to show you how you can apply what you've learned in manipulating images, music, sound, and text to other kinds of data that are found in databases and data sets. We're going to start by looking at a play data set. It is going to be the passenger list of the Titanic. Now, you probably know what the Titanic is, right? It was a passenger ship who, on her maiden voyage, collided with an iceberg and then sunk. There's a great movie. If you haven't seen it, watch it. Too long, didn't read. A lot of people died. The ship sunk. There's a passenger list we're going to look at. And with this, we're going to explore how data sets are handled in Snap. And here's one takeaway right before. It's exactly the same as pixels or sounds are handled. So let's first find the data set. You can download it on our page. It's the dataset of the Titanic passengers. Once you've downloaded it, you can find it in your download folder, Titanic CSV. CSV stands for comma-separated values. That's a very common format for sharing datasets. Once you've found it on your computer, you can just, as with all the things in Snap, drag it right into Snap and just let it go and drop it. And this is what happens in Snap. It will create a new global variable with the name of the dataset. Here the name is Titanic. It will open a dialog box giving you a preview of what's in the dataset. And you see, here's a table with a bunch of columns with 888 rows, and there's data in there. Also, what you see is on the stage, there is a variable watcher that is showing you the contents of that variable. It's the same thing that's inside the dialog box. So we can close this dialog box, rearrange this watcher or monitor on our stage to examine what's in the data set. Sometimes it's great to again look at the data to get an overview of what's in. To do this, you can just drag the variable somewhere into the scripting area and just click on it once. Remember, if you click on a reporter in Snap, you get a speech balloon, a result bubble, with what that variable refers to. Here the variable refers to a data set, which is a table. Double-clicking on something that's in a result balloon will open the table again in the dialog box. So when I'm saying this is a table, you've seen tables, right? We've shown you the pixels of an image. And remember what we told you, that whenever you see a table really is nothing special in Snap. It's just a list of lists. And remember, we can even see this by right-clicking on any table and choosing List View. And when I choose List View here, what happens is I'm seeing the exact same data as a list of lists, and I can scroll through this and it's the exact same thing. So I can look at an individual sublist and see what's inside here. So it's just another way of representing, of showing, of displaying the data. So here we have a list of 888 rows. Now, a row in a database is also called a record in data science. And we're having 7 columns. Actually, it's 8 columns. And a column in a table in a database is called a field. So when I say a record, I'm referring to a column. I'm referring to a row. when I'm referring to a field, I'm referring to a column of data. So we can already browse through and see what's inside here. And as you see, the first entry, the first record of the database is very commonly the names of the fields, the names of the columns. So here we have an indicator whether that person survived. We've got an indicator telling us which class that person traveled. We've got the name. And here's, if there is something that appears to be cut off and you want to see everything, you can just go to the column head and use the mouse to drag it and then kind of until you see what you want to see. This is how you can manipulate the view on the database. So how do I access things in a data set? Well, since it's just a list of lists, same as pixels, remember, the items of that list are the records. So when I take the item reporter, the item 1 of Titanic, that's the first row in that data set. If I click on it, sure enough, I'm seeing the very first row of the Titanic data set, and that first row is, remember, the names of the fields, the title of the columns. So if I look at the second item, I'm getting the second row. This is Mr. Owen Harris Brond. So this is how I can access individual records. So the record number 5 is what's in the 5th row, the 5th record of my database. That's not too hard, right? So what would I do to get everything inside a column? Now I'm getting one row. What would I do to get a column, like all the names that traveled on the Titanic? Now, this is something where I'd have to go through every record and to pick the third column, the third item. Remember when we showed you the superpowers of computing were higher order functions: map, keep, combine. So we told you that map is almost the best thing on earth. Let's try map on this. Map takes as input a list. Here it is a table, a list of lists. And now we want to get something from every entry in the list, from every record. Now from every record, we want to get the third entry. If you mouse over the header of a column, you can see its index number. So if I mouse over here, you see 3. So I'm getting the item 3 of every record. If I now click on map, see what I'm getting? I'm getting a list of all the names. I'm also getting the title of that column. Sometimes I don't want to do that. So it's a great practice that when you look at data, when you see the names of the field, but when you do the actual computations, you want to ignore the names and just get the plain data. This is where you can use the all but the first of block. So if I'm getting all but the first record of Titanic, this is 887 records, which is the whole table without the first record that has the title of the names. So if I want to get all the names, this is what I would do. And now I'm getting a column. Okay, remember, item of gets a record, map item, and an index of gets a column of a table. So how could I get a range of records? Let's say I want to get the range, I want to get the first 10 records in that data set. Now, I could do this with a loop, but I can also do it with map. Here's a little trick. You can get the numbers block. The numbers block reports a range of ascending or descending numbers. Hey, look, it's already set to 1 to 10. If I click on the numbers of 1 to 10, I'm getting a list of the numbers of 1 to 10. So now I can actually map over that number and take the item of Titanic inside the ring. So now what I'm mapping over is not the records of the Titanic, but just the numbers of 1 to 10, and I'm getting the records by the index. So if I click on this, sure enough, I'm getting another smaller, a part of the database that has 10 records in there. And you already see the first item again is the header names of the fields. If I don't want to get those, I'm doing all but the first of Titanic, then I'm getting the first 10 records that actually contain data. What if I wanted to rearrange the columns and get maybe the name and the sex and nothing else? Now in this case, remember, getting a column is mapping an item off over the whole database. So if I want to get one column, I'm mapping the item 3 for the name over the Titanic. Now I'm getting all the names. What if I also want to get the genders, the sex of the people? Now I could use another map block inside the ring and then use some fancy scoping, but here's a trick that I'd like to do myself. We can just take the list block, expand it by 1, and do the same thing that you did, remember, when you were manipulating the images, the pixels of your image to swap the color channels. This is the same thing we can do. So now we've got the item 3, which is the name, and item 4, which is the sex. Now if we execute this, we're getting a range of just those 2 columns. And you know, here's one thing: if we want to rearrange them by having, for example, the sex first and then the name, we can just rearrange them in the reporter that creates each record. Remember, we can use map to transform data, and just the same thing that we've done for pixels in an image, we can do with the records and the fields in a database. Easy, right? So we've now seen how we can access individual records, how we can access a range of records, how we can access a single column, or how we can make another partial database containing of several columns. What if we want to get a logical part of the database? What if we wanted to find out how many people survived the sinking of the ship? Now in the first column, you see that there is a 0 for if somebody didn't survive, and a 1 if somebody did survive. So now we'd have to filter the database for those who did survive. Remember filter? When we showed you in the last week that there are these superpower blocks, here's a block that is called keep. And we can use keep to only keep those records that fulfill a certain criterion. So we're keeping all items in all but the first records of the Titanic, because the first record, those are the header files. And now in here, we can put a hexagonally shaped predicate that specifies which ones we want to keep. So we want to find out whether what's in the first column equals 1. So we go to the operators category and put out the equals block, which is going to be our predicate. We're going to say something is equal 1. Now what is it that is equals 1? It's the item 1 of whichever record. So we're taking the item 1 off block here, and this is going to be our predicate. This is our test expression. So now we're going over the list and we're finding out all the people who survived. Let's click this. So now in our first column, We're only getting those people who survived. And this is how we can filter a database. And we also see that this is only a part of the database. Only 342 people out of 887. Wow, we've just found out something else. So now we can also count what's in there. We can say, here's the length of the part of the people that survived, the length of that database. The length is 347, and we can make a fraction put that into relation to all but the first of the Titanic, actually not the whole list, but the length. Now if we click on this, this is the fraction of people who survived the disaster. If you want to put that as a percentage, we can multiply it by 100. So we see that about 38.5, 38.6% survival chance was there if we don't look at other criteria. One thing of your exercise is going to be to find out how other criteria might have affected the chance of survival on the Titanic. But you already can see, we can get ranges in a database, we can make search expressions and filter the database, we can use the length of block to count the records that we found, and this lets us gather insights and find out certain things about percentages of records versus the whole data set. Remember, there was one last block that we showed you when we showed you the magic of higher order function. The last block was the combine block. Now, remember what we used combine for? When we made the acronym function, we used combine to concatenate text together, to add things. And that's really the quintessential and most common thing that we use combine for. We can use combine to add up the numbers in a list. So here's the numbers from 1 to 10. If I want to get the sum of the numbers of 10, I can combine that list with the plus block, and I'm getting 55 as the sum of the numbers from 1 to 10. Now, in the same way, we can aggregate values in a database. If we, for example, look at the database of the Titanic again, I'm dragging this out, I'm clicking on it, I'm double-clicking on it to get, again, the dollar box. I'm seeing in the last column, in the 8th column, I'm seeing the fare that the passenger paid. So I want to know the sum of everybody's payments to ride on a sinking ship. So in order to get all of this, I need the 8th column. So remember, to get one column, we're mapping the item over, again, all but first of the Titanic. To get the 8th column, I'm putting in 8 here. So now I'm getting this column of what everybody paid. Now I just want to add us all up. So instead of the numbers from 1 to 10, I can put whatever is in here and there. And now what I'm getting is the sum of all the fares that passengers paid. And just again, to put this into perspective, we can now compute the average fare that a passenger paid. And the average fare would just be, we're dividing this once again by, again, the length of all but first of the passengers. And this would be the average fare in British pounds, 32 pounds and 30 pences that people paid to ride on the Titanic. This is it, folks. You already know about data science. As you can see, this is a small data set, just 887 entries. You're used to way larger data sets when you take a picture of yourself. Now you know how to access individual records, how to access individual fields, how to get ranges of fields. There's a bunch of interesting questions. We'd like you to find out about the passengers on the Titanic, and I can't wait to see your solutions to the problems we've posed for you. See you tomorrow.